Having moved all my work in R from RStudio to Positron, I thought I'd take a look at Databot, and that's exactly what I'm going to do in this video. Now, there's a little bit of setup that I'll talk to you about in the beginning, but let's see what we can do with Databot. And so we're going to start by looking at the Positron website. I'll leave a link to this page in the description down below. It's about getting started with the AI assistants that are available in GitHub Copilot, and you really have to read through this and work through this to set it up. The first thing, of course, is to enable Positron Assistant. And if you have Positron open on your system and you click on this little link, it'll open the settings for you and you can just follow that instructions. That's quite easy to do. And then we've got to set up some large language model to be able, to use generative AI inside of Positron. And there are two ways that you're going to go about it, and that's using Anthropic or GitHub Copilot. That's what we have at the moment. It's important to read what it says here. Currently, we support Anthropic and GitHub Copilot for sidebar chat. And so that's where you chat to the chatbot on the side in the IDE, and then inline chat being you're writing code and you can put a prompt right there where you're writing your code. But it warns at this time only GitHub Copilot is available for inline code completion. And so that's quite important if you're creating a notebook or quarter document and you want to do that inline chat as you're writing the code, then yes, you've got to use GitHub Copilot. And then very conveniently, they have the two sections here for you so you can set up Anthropic. Now that is going to require you to load some money into your account or have some access to funds in your account so that you can use the API, and you've got to set all of that up. Now that does take some time, and you can simply click on that link and follow the instructions. It's not very difficult. You can see the picture down here. You've got to go to Anthropic. You've got to go set up an API key that has to be loaded with money, and you're going to just copy and paste that API key here. When we choose GitHub Copilot, that's perhaps the easier way to do. If you are in GitHub and you do have a GitHub account, sign in your default browser, and then you can just authorize your account. You can select this instead of using the API key. You do the authorization, you sign in, and because in your default browser, as we are here now, it'll open the right pages as long as you've already been logged into your GitHub account by the time you hit that sign up. So you must follow these instructions and set up either one of these. Now, I'm going to say that I have both of these. I do have Anthropic set up. I do have the $20 a month account with them. And, I load $10 at a time just for use of the API. And that really, that can last a long, long time. It's really not that expensive. And then I also have a subscription to GitHub Copilot. I do that because I am with a university, and so I do not pay that $20 a month. I have a faculty account there, and so you have to consider that as well. Of course, you can use GitHub Copilot. You can use the free version, and that's just going to limit the models that you have access to, but that will still definitely work. But for full transparency, I will say that I do have access to both of these. So my system at the moment is set up to use GitHub Copilot because I use Visual Studio for most of my coding and data analysis. And so I do have this set up anyway, and that's a very simple thing to do. As I said, in my default browser, I had my GitHub account open on the GitHub website, and I just clicked on this button, set authorization, signed in, and there's a few clicks and you are done. When it comes to this Positron Assistant, this is the second web page on the Positron website that I just would link to again in the description down below, and just gives you a little bit of information about the chat pane, the inline chat, and the code completions. And so we saw on the previous page that we need GitHub Copilot for the code completions and this inline chat, and it's just worthwhile just to do this getting started guide. It's really not that difficult, but you have to go through these. And so here I am in Positron, and I've clicked on the Explorer button on the top left, right there. So we can have the Explorer open, and I'm just going to drag a folder into this empty section here. So I've got my second monitor. I'm just going to drag that across, and there we go. And we can see I have two files in this folder. One is called heart.csv. If I click on that, we see the Data Explorer opens up, and that's actually quite nice. Because in this Data Explorer in Positron, we can see there are all the column headers. So those are going to be my variables. And we see a bit of information about the data. I can just open up one of these. We can see a little histogram of the age. We see there's no missing values. The minimum age was 28. The maximum age was 77. We see the mean and the standard deviation there, the median. And so you get this little bit of information about each one of these of your variables. We can see that there were 2 unique values in the sex column. And then, of course, if you go in here, there's all sorts of things that you can do, such as filtering and sorting by ascending or in ascending or descending order. So it's a nice way just to go through. You can just side scroll and you can go through the whole data set as if you're opening it in a spreadsheet. So that's great. The second file that I have here, and I'm very insistent on this in all of the work that we do in my research group. And so we will have a data dictionary. Now I'm going to again leave this in the description down below so that you can have a look at that. And the data dictionaries usually for us are just simple markdown files, and you can see we're just using very simple markdown. So single hashtag in a markdown file that denotes, the largest font size. So that's typically reserved for your title. So I've got a title data dictionary for the heart.csv dataset. I've put those in little tick marks. If you put those in those little tick marks, usually for an LLM, it's easy to recognize that you're trying to use code. And so I'm going to say, well, this is what I would use in code. And to be more specific or pedantic about it, let's put some quotation marks around that as well. So those little tick marks indicate that this would be code, and the code is the string heart.csv. So this is what I have. This document provides detailed description of the columns present in the heart CSV dataset. And here I just put it in quotation marks just to indicate again that it's a string. You don't have to do any of this, which contains information related to heart disease diagnosis. The alternatives column below shows the words and terms to use when creating plots and visualizations based on this dataset instead of using the column headers, which are abbreviated words or words with underscores. And so that can be irritating. If we go back here, you see we've got st_slope, and we've got old peak, we've got angina exercise angina with no space in between, or max HR. These are not the kind of words that you want to see in your plots. You wanted to say resting space ECG and maximum space heart rate, those kind of things. So our data dictionary even has that in as a column. Now it's too big for the screen, so it looks a bit horrendous. Yeah, I've opened it up in a text editor and I've just made it very small so you probably cannot read, but if I had enough screen real estate, which you don't have in a YouTube video, you can see this is how it is done. You create columns in Markdown by just using this, the little pipe symbol on your keyboard. And so there's your column headers in the first row. The second row indicates with this colon that we put there. Hopefully you can see that on the left-hand side, which means everything will be left aligned in my column. And then each row is just one of the variables in my data set. I've got the column name there, the data type, the description of what that variable means, the encoding if there is. For instance, in the sex column, we'll have an M for male and an F for female. And then in the final column, alternatives, if it says max HR, use the term maximum heart rate. And so this is our typical data column. This encoding probably is most important because it would say things like 0 means false and 1 means true, 0 means no, 1 means yes, or 0 means no heart disease, 1 means the presence of heart disease. So this encoding is very, very important. So always, always, always have a data dictionary. And so that's what's in here in this data dictionary file. And so let's save this. And I'm just going to close it up, and I'm going to close the heart.csv file as well. And the time has come for us to use the Databot. Before we get there though, do remember there is our little chatbot. If I open that up, we see welcome to the Positron assistant. It's already set up for me. I can use the agent or I can just chat. And I've got access to all these models because I have linked up to my GitHub Copilot account. And so I have access to all these models. I usually keep it at Claude Sonnet 4.5. which for me is sort of still the best. It's not the biggest model. It's not the Opus 4.5 model. So it's a bit cheaper to use because you are going to use some money from your account if you do that. Of course, right here, because I'm using my GitHub Copilot account, that's all within the $20 a month. And so you followed the instructions on the web pages that I showed you right at the beginning. And so now we want to start the Databot. I'm going to hold down Shift and Command and hit the P or Shift Control P on a Windows. And I'm going to type open Databot. And because I've used it before, it's right at the top as one of my frequently used commands there. So open Databot, if I can spell that correctly. There we go, open Databot, and that's what I'm going to do. And the Databot is opened. Let's just close this chat on the left-hand side, give us a bit more space. It gives you a couple of suggestions of things that you can type. And you can see right at the bottom is where we are going to type just our prompt. And I'm just going to say load the, and let's put that inside of quotation marks. I'm going to say heart.csv file in the current folder. So that's all I wanted to do. No analysis yet. Let's just load that file, and that's all I'm going to say. You can see my model is Claude Sonnet 4.5. I'm going to hit the return key or the enter key. Let's see what happens. And it's done a tool call for us. This is an agent after all, and it's done this execute code tool. And it's written some code here, as we can see, execute our code. And it's the typical thing. It's going to load it using the read.csv, which means it's going to create a data frame object, so not a tibble. And then it's just going to display those first 6 rows of data. Now, I can say allow always, which I'm not going to do right now. I always want to look at this code before I choose to run it. And there's various things that we can do, of course. You can look at these buttons. You can copy it. You can insert it at the cursor. You can insert it into a new file. And so I'm not going to do any of that. What I'm going to do is just say allow once. And there you go. The code has been written, and we can see the data is imported. There's our first 6 rows of data. And it says, great, I've loaded the heart.csv file. The data set appears to contain disease-related data for the 12 variables included. So I'm just going to say read our data dictionary. And it says, perfect, I've read the data dictionary, now I have a complete understanding of the heart disease data set. And that's so, I think, so important to do, to always have that data dictionary, specifically if you have spreadsheet files that has very obscure words in the header row. Sometimes you do find spreadsheets and it'll have something like PV2178 as a column header name, and who knows what that variable means. It's important to have a data dictionary and also to explain what encoding you used for data in the spreadsheet. So that's absolutely great. Okay, let's do some univariate data analysis. And so I said, let's do some univariate data analysis. Start with the age column. So let's just put that in quotation marks. It is a variable with a numerical level of measurement. Calculate the sample mean, variance, standard deviation, minimum, first quartile, median, third quartile, maximum, and the interquartile range, and create a histogram using the ggplot2 package. I'm putting those in tick marks just to indicate to the LLM that this is code, and it's usually a useful thing to do. You can be much more pedantic about it. Use JSON, for instance, in your prompts. But we're just trying to keep things as simple here as possible. So add an appropriate title and axis labels, and add a grid to the plot. Let's see what happens. And it's written some code. Let's inspect that. It's created a variable to hold all of these values. Now there are packages that have describe functions or describe by functions, like the psych package. But it's decided it's going to do this all, by writing explicit code. And so it's going to have this list of key value pairs. So the mean is going to be the mean of that column, the variance, the standard deviation, minimum Q1, median Q3, maximum, and the IQR. And it's going to print the descriptor statistics for that age stats. And so the code looks good to me. Let's allow once and run that. And we can see descriptor stats for age. We see the mean was 53, the variance 88, and the standard deviation 9, minimum 28, then first quartile 47, 54 for the median, 60 for the Q3, maximum 77, IQR 13, and now it's created some code for the plot. If we look through that, it is the library ggplot, it's calling that, the ggplot function. We see the data set and the data frame is heart. We see the static there is x-axis is age. We're adding a geometry, the histogram geometry, a bin with a 5, and it's filling it with steel blue, with a color black, and alpha value of 0.7. Then it's adding some labels. Then it's using the minimal theme, and then it's adding some a major grid, a grid pattern, and then a plot title. Element text is just doing some adjustment there. Let's have a look. Allow once, and there we go. There's our plot. And we see age in years, the frequency, the distribution of patient age. That looks great. And on the right-hand side, of course, we are going to get a copy of that plot. Remember, up on the top right, we're going to see the variables that have been created thus far. And it's even done a nice little write-up for us here. There's our descriptive statistics, and then the key observation. The histogram shows that the age distribution is approximately bell-shaped with a slight left skew. Most patients are concentrated in the age range of 50 to 60 years range, with the highest frequency around the 55-year-old. The distribution spans from 28 to 77 years, with a relative few patients under 35 and over 70. And I'll, do some, suggest some next questions. And so that is absolutely great. Let's just go back to the top. We see that the next variable there is sex. Now I'm going to do that one as well. And you'll see why I decided just to say here this is a variable with a numerical level of measurement, because later on I want to say just continue with all the variables and do the appropriate thing for numerical variables and for categorical variables. So let's do the next one. And then say, I'm going to do spell checking for you, so you've got to do that yourself. Add an appropriate title and axis labels, add a grid to the plot, summarize the information as before. I didn't say my instructions were not to create that little summary information, and I quite like that it did. So I'm just going to make sure that it keeps on doing that. And so let's see there, it's created a little table of the frequency and then the relative frequency. It's created a little summary data frame for us with the names, the frequency, the relative frequency, using the values from the table there. It's done a percentage by multiplying by 100, and then it's going to print that. Let's allow that once. And so we can see 193 females, 725 males, and we see the frequency and the percentage there. That's great. It's now created a ggplot for us again, redundantly. It's importing the library again. It's already there. And we can work through that. It all looks good. Let's just say allow once, and there we see a very nice data visualization. What I don't like is, of course, it hasn't given enough space there, so you need to add some space if you want to print the values at the top. And so we can certainly instruct it to regenerate this plot. I'd advise you to do that and create a bit more space, or just to omit these values. I like these horizontal the grid, because it draws your eye and you can see the vertical axis and read from that the approximate value from the plot. And it's given us a nice little bit of information there. The data says heavily skewed towards males. 4 out of 5 patients compared to the females, 21%. We see the ratio there. So a nice bit of information. Just by the way, if we go back to this, I probably asked to recreate this plot, because I don't like this default of creating X amount or N amounts of bars. I really want to go from 20 to 30, say 30 to 40, or 30 to 35, 35 to 40, 40 to 45. So you can set those the limits as well. So I might have written another prompt to say, just change this for me, but it's not that important for us now. But if you don't like these plots, you can always do that instruction. So now that I've done a numerical and a categorical variable, I'm going to say go ahead and do the rest of the exploratory data analysis, calculate summary statistics and data visualization appropriate to the level of measurement of each variable. So I feel sort of comfortable that I can do that now that I've had one numerical and one categorical variable as an example, and add a summary to each. Okay, it just wants to create or print at least the structure of our data frame object, which is something I do in my notebooks all the time. It's part of the sanity check right at the beginning of my notebooks when we've imported that spreadsheet file, just to make sure that we have everything. And so now what I'm going to do is just allow this once. Of course, you should take time and read through all of that, and look at this. It's found an error in its own code. Let's see what happens now. And it seems to have refactored that. And there we go. We see the chest pain type. And look at this, asymptomatic, atypical angina, non-atypical angina, and those are certainly not the words that were used in that column. Abbreviations were used, but because I've got that data dictionary and I've got that final column which talks about those abbreviations and what words to use instead, I get these beautiful plots, and everything is done appropriately. Once again, we don't have enough space at the top of our plots, and that's something we might want to fix. And we see resting blood pressure now. And so I'm just going to say allow always. Now, I won't do that in production because I want to read all of this code myself. So we've got the resting blood pressure. We have the distribution of serum cholesterol. By the way, some of these columns have zeros in them as observations, but in my data dictionary, I clearly indicate that when there's a zero, that is an indication of missing data. That's also in my data dictionary. So those values would be excluded from all of this analysis. So I can trust that that was done correctly, and you've got to do that just by interrogating the code. There we see our maximum heart rate, the distribution of exercise-induced angina, see the summary statistics there of the ST segment depression, the distribution of the ST segment depression in millimeters, distribution of the ST segment slope, so downslope, flat slope, or upslope, indicating the lack of oxygen supply to the myocardium, distribution of heart disease diagnosis, 508 with heart disease, 410 without. And we are now going to see the summary of the data exploration. And we have that nice summary. So let's ask, now it's done all of this, how do I save all of this? I'm going to say, can you create a notebook of all of your analysis? So can you create a research notebook of all of the analysis? And look at the plan there. It's going to create a quarter document for us with a title and the sections: introduction, data loading and structure, data dictionary overview, univariate analysis, data quality assessment, key findings, summary, and a conclusion. Does this outline look good to you, or would you like me to modify any sections? Let's just say it looks good. And it's generating our quarter document. And I absolutely love this. If you look here, you can see that it is using this sort of code completion. So it references the values from the analysis. So if any of the data changes, so for instance, you are using add some more data to your spreadsheet file, it's going to upload the values next time you run this notebook, because it's referencing the values from its analysis instead of hard coding or writing in the values within the text itself. I'm just going to say the following. So change the YAML so that the HTML rendering exports a self-contained HTML file. And it's added that self-contained equals true, set to true at least in the YAML. And so it's rewritten that for us. And let's just say render the file. And there you go, it's done. Let's open up our Explorer and we see we indeed have a heart_disease_eda.html file. I'm going to open that in a browser. And there's our notebook. And look at this first part. It says this report was generated using AI under general human direction. At the time of generation, the content have not been comprehensively reviewed by a human analyst. And so just to show you, if we go back, just create a little bit of space here for ourselves, there is that text, and it has a little code comment, and it says to indicate human review, delete the line above about contents not being reviewed and replace this comment with the contents have been reviewed and validated by, and you can put your name, your role, and your date. Just a little suggestion of what you can do there. So I think it's very nice that it does that. At the moment it says that. Now, I reviewed some of the code as it was written, but I really do advise that you review, of course, all of that. And look at this. There's our nice HTML file. And if we scroll down, see the import there. It has this little warning, resting BP and cholesterol, use 0 to indicate missing values, not actual measurements of 0. And that was in my data dictionary. That's absolutely fantastic. We see the results right here. It all looks very good. And again, it says the cholesterol has 172 missing values, 18.7%, which is substantial and should be addressed in any predictive modeling. That's a very nice warning there for us. We see the maximum heart rate, the ST slopes, and then it's going over to the categorical variables, or variables with a categorical level of measurement, warning us against the imbalance that we do have, the chest pain type, etc., etc. You can just look at this. A little tooltip there. The target variable is relatively well balanced there, positive and negative cases. Data quality assessment I did for us there, key data quality issues, key findings, important clinical patterns, a conclusion, and recommended next steps. And so all in all, I think this is a great success, and I really want you to try the Databot for yourself, upload or have a data set ready, and see what it can do for you.